All right, welcome everybody. Today we have a repeat appearance. Well, it depends on how long you've been with us. We've had Daniel before in a lightning lesson, and I'll let Daniel introduce himself a bit more. But the background of this lesson is when you're doing RAG, a lot of the focus nowadays is on very unstructured data, like documents and so forth. But most business data is structured, like tables that you might have in your data warehouse, SQL tables, so on and so forth. And when you're asking, when you're trying to answer questions or solve problems, a lot of the answers you're looking for are in that structured data. And so Daniel has a long history of working on information retrieval, machine learning, things like that. He's currently founder at Superlinked, and he's gone very deep on this topic of structured data retrieval and retrieval in general. So I'll hand it over to Daniel. The,
Yeah, perhaps too deep. Thanks, Hamo. Um, yeah, hey everybody. Yeah, basically, the intro was pretty spot on. I think the magic happens at the combination of unstructured and structured data, right? The unstructured parts being, text images or screenshots of PDF pages, but then also the metadata that comes along with it, right? Timestamps, numbers, coordinates, latitude, longitude, behavioral data, all of that, right? So I think this today will focus on how to take advantage of all of those signals in your information retrieval, right? It could be retrieval for RAG, but it could also be traditional search recommendations, matching different entities together, and so on. I prepared actually new slides compared to the lightning talk. So if you joined that one, this should be somewhat of a variation on that, but not quite the same. Let me see if I can share this. Um, okay. Can you guys see the
yeah, I can see it. Yeah.
the two smiley faces?
Yeah.
Just the amount of teeth on this slide is insane. So I think we have that going. And then we had that comment about the hair situation that kind of looks different, at least from for me. Um, okay, so I'll kind of go into the use cases, but first I'll kind of set up the problem. And my whole angle here is that you can make your vector embeddings understand more than just the unstructured bits, more than just the text and images. You can somehow inject the metadata and other signals into the embedding itself, and this is helpful for various reasons that we'll get into. But I'll just dive right in, and I'll try to somehow go faster than last time, so we can actually have some questions at the end. So, but I talk a lot, so this might be tricky. Okay. Um, I wanted to motivate the whole conversation with just one query, and this is from the travel use case, right? So if you look at this query, popular family-friendly hotels with good Wi-Fi near Manhattan Midtown under 400, um, there is like a bunch of things going on in here, right? That illustrate the point of why you would want to combine different signals. Um, as you are kind of looking at this and going through the course, I hope that you already have some ideas for how you would handle this, right? Like how would the system look that would be able to answer to a query like this with relevant results. Um, but if we kind of like break it down into okay, what's actually going on here, you have like a reference to a couple different biases basically, right? And then one filter. So you have popular, which is you want to create a skew towards some sort of numerical variable that tracks popularity in its simplest form, right? It could be popular contextual to a specific user, right? And then you go into kind of more higher cardinality representation to be able to do that. But perhaps just a number is a good starting point. Family friendly might be something around categorical properties of the hotels, right? That you might infer from comments, but it might also be in the underlying data set. So categorical property is important. Um, and then, there is like good Wi-Fi, which is there are different ways to say that, right? So some kind of semantic search may be going on there. Um, near Manhattan Midtown is like a location bias, right? You want to skew towards results around certain location. And then under 400 is just filter intent that you would want to somehow infer from the query text, right? So bunch of different things going on. And in terms of, as you're kind of thinking about how can we deal with that? Um, I think for most people, they're sort of looking at something like this, right? On the left side, you might have the conversational query. That's what we just saw, or natural language query, whatever you want to call that. I think that's what people mean when they say AI search, basically. But there's like other things going on, right? There is context of the user. So it's some kind of user ID searching for that, right? So there is potentially some history of the user, some current, the user is maybe in a location right now, right? So there might be some current context, some historical context for the user. And there might be other context for the search happening, right? It might be like certain time of day, uh, all kinds of other parameters of that situation. And the question is, how do you go from those inputs to something like a search query that then goes into the database and actually handles all of those different objectives there? And I think most people go to some variation of text to SQL, right? They try to take that natural language query and generate like a SQL query or OpenSearch big query JSON. In the Lightning talk, I made like a landscape out of that JSON because it's typically like very complicated. Um, and and then, as you generate the query, it will have all kinds of different components, right? It will maybe pre-filter on things. It will boost on certain, attributes. There might be semantic search. There might be re-ranking afterwards, and some kind of post-filtering once maybe you establish some kind of distribution of those candidates. Okay. Now, this is a bunch of issues, of course. Text to SQL, if you use it to power some kind of user-facing experience, you care about latency a lot, and these things are pretty slow. And then also because of how many degrees of freedom you have in SQL, this is not super reliable, right? You can generate all kinds of things. So there is problems in the upper box, and there is problems on how do you actually shove the non-query text elements as an input to text to SQL, because it's not actually text, right? The user context, what did the user click on, uh, and all kinds of other aspects of that context are not textual, right? And this takes text on the input. So what's up with that? How to reconcile that? That's typically kind of part of why what most people start with is not at the same level as I was at YouTube for 6 years building ML systems in the ad stack, and when you train custom models and feature engineer all those inputs, then you have a chance to do it. Okay. Now, even if you did all of this and you generated the perfect pre-filters and you figured out some boosting and you figured out how to do re-ranking, there are still issues. I would like to, and those issues come from kind of the core of your retrieval, core of that semantic match being text only. And so I have like 3 examples for that. So a lot of for this kind of query, a lot of what people do is they try to convert the biases into filters. So they kind of overuse filters, right? Popular might create like a thresholding filter on the popularity. Near Manhattan Midtown might create like a geo circle or like a distance circle around certain location. And when you do that, when you try to model some kind of preference function that's smooth for the end user, because there is no specific threshold that represents near Manhattan Midtown, right, or popular. Then you are basically approximating some kind of sigmoid curve with the step function, right? Because filters are just in or out, right? So there is obviously going to be a loss that comes from trying to model biases with filters. Re-ranking, and this is somewhat controversial, and um, you should really like make up your own mind about this. But basically, re-ranking is just a hack that was inserted in information retrieval systems that couldn't in the candidate generation actually surface the correct results, right? Like nobody actually wants to do re-ranking. If we could magically somehow make our retrieval system fast enough to update and use all the signals that it needs to use, nobody would be re-ranking, right? And you know, like I would love to maybe get a question around that or be challenged there, but basically that's somewhat of a controversial idea. And the problem of re-ranking is obviously that you are applying some kind of scoring function on a tiny subset of your index when you do that, right? You generate candidates. Let's say you do like popular pens, and what if half of your database is pens? So you can't just get all the pens out and order them by popularity, right? Then obviously your recall is not going to be good. And then re-ranking adds latency, and you're moving stuff across the network, and it's all just a consequence of the retrieval, the underlying retrieval being poor. And then kind of one way people try to work around some of these things and push more into the vector search part by stringifying more of those signals on the left and encoding them into a vector using a text encoder. You can, in principle, stringify anything you want. But of course, if you have numbers in there and you try to encode them with a text embedding model, it will tokenize those numbers as strings, and it will use like a fuzzy understanding of what those tokens mean in terms of their underlying math, right? So this is an experiment you can reconstruct by basically taking embeddings of the integers from 0 to 100 and calculating, let's say, similarity between the embedding representing 50 and all the other ones. And you would want some smooth drop-off as you go away from 50, and you get the noisy black line. Because stringified numbers don't embed accurately with a text encoder, which shouldn't be super surprising. So these are some of the ways people go wrong, and this is what ultimately impacts your retrieval quality and cost and latency and all that. So what can we do instead? Basically, imagine that you have some kind of box that takes all these inputs natively on the left side, and it stuffs as much of that signal as possible into the actual embedding. So let's say the embedding is now metadata-aware. It takes all of that context into account along with the query. And if you absolutely have to, like the under 200, okay, you generate the filter also, right? So, you shouldn't be using like dense representations of things to somehow try to have a filter if you really need a filter. Like some kind of sparse data structure for that is much better. And all the databases now offer filters, so this is not a problem. But basically everything else you should try to stuff into that vector. That's kind of the part of the debate that I represent. And that's the query side, right? The left side. The right side is
Can you go back to that
yep,
previous slide if you don't mind?
yep.
So are you saying that when you say the camp that you represent, are you saying like effectively you think that you should make your vector search so good that you don't need re-ranking?
No, you should. You should. You
You
should.
should. Okay, it has a line through it. I
Yeah.
just want to make sure that I understand.
You shouldn't re-rank, right? Like no re-ranking. So what I'm scratching out, you should stop doing the scratched out things. Yeah, maybe I should have made it like a white line, not orange line. But basically I'm saying out of all these things on the right, like ideally you scratch most of them out and you just do filters and vector and similarity search, basically, if you can, right? Like all the other stuff is basically just you compromising from this perfect state, right?
Okay. So no re-ranking. So
No,
no,
ideally,
ideally.
ideally.
Okay, that's really interesting. That's like a little slightly controversial.
Yeah, it is. And like to be honest, if you think from first principles, right? Like I don't understand how somebody can take the position that like I'm going to be like in the ideal state, I want to be re-ranking, right?
Sure, yeah.
Like in principle, nobody should utter such sentence, right? Like in the ideal state, you actually don't want to re-rank. You want the 10 things coming out of your database to be the best 10 things. And then people say, okay, but wait, but like then we have to update the database more often. Or we have to, I don't know, figure out how to encode more signals in there so that it's comparable with the re-ranking, right? But all of those are like just, okay, so like go do your job, right? Basically. Because the
Okay.
ideal state
Yeah.
is there is no re-ranking, right?
I think
So
the thing it'll be not you probably will get to this, but like can we get there? Do you think we can get there to a place where we don't need re-ranking?
I think we can get to a place where we do re-ranking maybe like 20% of the time, or less, right? Um, I think, and it's the same with like trying to model all those preferences as filters. Like I think our filter usage should drop severely. Uh, Boosting as a concept in OpenSearch is basically you're trying to do the signal mixing with some kind of primitives of OpenSearch. In principle, there is no need for that because any like smooth function in terms of that bias can be represented in the underlying embedding, right? So, and of course, it's much more powerful in that way because you can choose all the encoders, right? You can, for example, for the geo kind of boosting, you can have an encoder that approximates the travel distance by car between places, and you can boost on how far it takes to drive from one place to the other instead of trying to yeah, I don't know, boost on like Euclidean distance, right? Which maybe is like a built-in feature of OpenSearch. So basically, it's like our line of thought is that the underlying database should be super good at filtering and cosine similarity and like sparse kind of similarity. And everything else should happen in the orange box in terms of the encoding of the whole problem and then on the other side, encoding of the data, right? So you have kind of the other side of this coin is that you need some boxes for encoding things like everything you know about your products or everything you know about your users, right? Or everything you know about whatever other entities you might have. So you need some boxes for that, and then you meet in the middle, which is then the vector index, which helps you match between those different objects. And again, filtering is actually useful. So you should sort of figure out how to do that because certain users can't access certain content, for example, right? So like you need filters for that.
And
Um,
I guess
mhm,
like the concept of filtering, you can pack a lot into filtering. It seems like even with the distance example that we're
mhm.
talking about, you could handle a lot of that in filtering potentially.
Yes, but you shouldn't
You
basically.
shouldn't.
If
Okay.
you if
Yeah.
because that goes back to the kind of trying to approximate these smooth functions with the step functions, right? Filter is very crude tool, right? Like you are in or you're out, right? I mean, this
Yeah.
is like as crude as it gets, right? And usually the thing you are trying to model is actually not that crude, right? If I say near Manhattan Midtown, like what is like if the thing is slightly better fitting on other dimensions, maybe I'm willing to travel a bit further, right? And so basically filters can be good, but filters are definitely overused. Re-ranking is mega overused. And the sweet spot for us, from our point of view, is you figure out the orange boxes, you encode all your entities as embeddings, everything you know about your users, everything you know about your content, and whatever else is important. You have embeddings that kind of compile all of those signals. And then based on top of that, if you want to do a predictive model, you feed it one of these embeddings and you reframe all your other problems into like matching of these vectors, retrieval, clustering. Basically, you can get super far that way, right? You can
I think
reframe
a spicy take of
classification
this
tasks.
talk, and I love spicy takes, is like you're that people are mega overusing re-ranking, and I think you're implying that their vectors, people are not being thoughtful about their uh, you know, vector construction
Yeah,
and
yeah.
things like
I mean,
that.
they kind of somehow, let's say you have like a product entity with 50 properties in a normal e-commerce, and you take the description and maybe image out two properties, and you make an embedding out of that. Okay, so you just make an embedding that takes as an input 2 out of 50 things you know about your products. So like your progress bar on figuring this out is 2 out of 50. That's kind of from my point of view, right? Okay. Right. So like how now so basically we reduce the whole problem into how we make this orange box, right? Or these like various variants of that box. And if you look at big tech, it's basically all custom encoders, right? You just go and you collect all these signals, everything I know about the given entity, you feature engineer all the signals, you kind of backpropagate error from the task where you then use the vectors, right? And typically you make this task specific, which is part of the issue, which is part of why it takes so long for each project to complete. But basically, you take that task specific loss and you train an encoder that combines all the signals, right? So that the retrieval is the most relevant and the most controlled. But this is hard and takes a long time and needs a certain amount of data. And just to be like super clear, I don't mean text embedding fine tuning here. I mean like from scratch making an encoder, right? Because as we sort of established, no amount of fine tuning of a text encoder makes it eat address and produce an embedding that is like map aware, right? And even like as simple things as numbers, like you can't fine tune a text embedding model to deal like super well with numbers, especially if you have multiple numbers in your entity and so on. Just because of how these things tokenize the input and it sort of breaks from there. Okay, so
Just
that
to clarify for people watching, what Daniel is saying is like not just creating text embeddings, not training just text embeddings, but basically a classifier over your text and all of your metadata and structured data and everything.
well, I mean, training a network that takes the whole, let's say, product from the product catalog as an input and produces an embedding that somehow in its position encodes all those 50 properties, right?
Hmm.
There will be like a cluster of expensive red shoes that are available in this location, but have been trending positively, and these kinds of users click on them, right? This will all be encoded in the position of that product in your space of products, because like that's all those things are super important for your e-commerce, right? Of course, this extends beyond e-commerce. Like this is just a general concept of you have some entities and you know things about them, and you should maximize the amount of these things you know about your entities when you create the embeddings. All of those signals
And in
should.
a classic machine learning regime, like this was often done in like e-commerce by looking at like page views, you know,
Mhm,
like what products are you looking at in a
mhm,
sequence, and
mhm,
basically
mhm,
feeding all of that metadata and everything you know about that and creating a
mhm.
rich embedding.
We would, for example, you would train a two-tower model, right? You would train, this would be an example of like what I mean here by custom embedding, right? You would feature engineer the users and items, and you would train this kind of network that can produce representations of both of those entities, and then you would have an index that matches between the two, and that's the basis for kind of most recommender systems out there that are kind of custom built. Um, but then, of course, the issue is that when a team in a big company builds that for, let's say, the landing page, then you have like 5 other pages that now need to, some sort of tweaking needs to happen. And then you have a bunch of other teams that would love to have efficient representations of this data, but can't really tap into it because the ML team is kind of optimizing this end-to-end pipeline, and it's just doing it for the specific purpose of people clicking on stuff on the homepage, right? This is kind of how this goes wrong in big companies. Okay, so that's our option number one. It's certainly the way to get for the given homepage with enough ML people and data. That's how you should do it, right? This is how you get the most value. But if you have 10 different opportunities to use this kind of data in a company, then it's simply you will just leave a lot of value on the table because you'll just rabbit hole into one purpose-tuned representation in that way. And so there is kind of an alternative that we see, and we have been working on this for a few years, where basically our goal was obviously to build a way to build those orange boxes. And we do it from like pre-trained components and components that are trained in an unsupervised way on the specific data set, right? So some sort of like minimal effort way to construct these orange boxes. Um, and because this is too hard. And I'll try to like not be super salesy, and I think I definitely want to leave time for questions. So basically, we just have a open source product and a cloud product that's commercial. Um, but if you have like up to, let's say, a couple 100,000 entities and like tens of thousands of queries per day, or maybe 100,000 queries per day, you can just run all our stuff on one VM with some GPUs on it and do it for free. And it's Apache 2.0. You can do whatever you want with it. For larger scale, then we have a cloud product and we work with companies. But basically, just the layout of the whole situation is that you have all your data on the left, and this is also like streaming and batch and different data types. You have all your use cases on the right, powered by these kind of embeddings, matching and clustering and retrieval. And the way we construct these models is by, it sort of looks like a mixture of experts. It's basically about combining different kinds of encoders together to kind of get this object level, this entity level embedding at the end. And then it's not quite just like API endpoint for embeddings, like you would consume a normal model. There is a state to this because some of those encoders are trained and so on. And so we opted to kind of design this as a thing that sits on top of a vector database, and it uses the underlying database for the cosine and the filters, as I mentioned. We have kind of first-party connectors and partnerships with Redis, Mongo, and Quadrant. We're adding more of those. And Superlinked manages both the kind of read and the write into the database, and also the setup of the schemas and everything from, like, you have a Superlinked data schema with all your entities and their relationships and all properties. And then from that, we generate the schema of the underlying database. Okay, so basically kind of trying to figure out the modeling compute problem in the middle of this picture. Okay, 2 case studies. I'll just super quickly go through this. These guys, Jobs Marketplace replaced Algolia and got 50% more people apply for jobs. And the thing I would highlight is that this is not really a search system, right? We don't think about it as like Superlinked is a search product. It's a product to build basically like vector powered software, which I know doesn't like yet make a lot of sense, but here it manifests by this company being able to build different experiences for the job seekers, but also for the people listing the jobs, right? To kind of manage the supply side of the marketplace, build different tools for people listing jobs and looking up the talent, right? The reverse problem of the jobs recommendation. And this is possible because our APIs are quite low level, right? We don't impose a lot of structure the same way a search API would look like. But then it also makes it like somewhat more confusing to understand. So, two sides of the coin. We have another thing like that with the fashion marketplace. The hotel search that was advertised, the case study didn't quite hit the public channels yet. So I won't be able to go like into super detail for that, but this is just another example in fashion. Obviously, multimodal makes a lot of sense. And again, sort of like very quickly from something like recommendations going into merchandising and all the surrounding tasks, right? Because we are, again, trying to help people build a platform from here, not just a point solution. And I know that this is like eval focused course, so I have 2 slides on evals, and then I shut up. When you look at I look at it from the point of view of benchmarking first, because if there is a data set out there that's like vetted and approved, and you can compare with others on it, that would be awesome to use, right? Not just your own, but some kind of standard thing. Unfortunately, all these well-established benchmarking efforts contain no metadata, more or less, right? It's just text query matched to text object. And obviously this is insufficient. As we established, that covers like some small fraction of all the properties of your data. And so you will have to create data sets, basically. That's the TLDR of that. And the hard part about creating eval data sets is, of course, the relevance labels, right? So you have your items, you have your queries. Ideally, both of those represent the reality of your production. And then the question is how to do labels. And typically, you do some kind of candidate generation there and then labeling with the large language model. And the problem is that the candidate generation is hard to make it metadata aware. And so, we like combine all kinds of different things to create candidates that at least have a chance. And still, the recall is very low, which just points to the issue that I mentioned about, like re-ranking and the recall of the candidate generation. So you pay a lot of money to generate a lot of candidates and then score them with the judge, taking all the metadata into account, taking those rich query objects into account. We have done this for many, many months, and we hope to release some data sets as well for others to be able to evaluate, fixing the shortcomings of some of the existing benchmark data sets. Okay, cool. So, I mean, that was somewhat haphazard
No, I
run
don't think it
through.
was haphazard at all. I actually have a question
Okay.
that's on my
And
mind.
yeah, like I would
Yeah.
love questions from everybody and sort of yeah,
Yeah,
just
the
point you to our
main
GitHub. That was my call to action. And you
you
can
should definitely check out the GitHub. This is a really interesting and cool project. Um, especially because of the structured data angle. It caught my interest as well, very early on. Um, so one question is, okay, there's a lot of buzz nowadays about like, I'll just put it in air quotes, agentic search. And,
hmm
people will like RAG is dead and all that other
hmm
BS statements.
hmm
Um, now, despite the terminology or whatever, the one thing that is interesting is, people are all these different experiments or different use cases where folks, like you, they'll say, okay, like you can't just over rely on semantic search. And so what we're going to do is let an LLM kind of drive a variety of different tools for retrieval. Like,
hmm
okay, like maybe using, like let your LLM use your classic search engine. Let
hmm
LLM write queries. Let
hmm
and maybe do semantic search also, and let
hmm
it kind of do this like kind of like how you would search if you were trying to aggressively figure it out in a way. And then maybe
hmm
bringing it back to the location example, like, okay, maybe saying, okay, if you have a database of hotels, ostensibly, like you have some search engine that allows you to sort by distance from a location, and then you would give your LLM access to that and say like, hey, give me a list of like just have it construct the query, you know.
hmm
in the
hmm
classic way or in you know, the uncool way of like, and then like bring me back list of hotels sorted by distance from a location.
Well, distance and price and I don't know what,
Yeah, yeah,
and
yeah, stuff
give
like
me
so. How
these
does
kind
that?
of distributions for those
Yeah,
things, right?
yeah,
Yeah.
and I
Yeah.
think like this was popularized recently by Claude Code and like they like um for their agentic sort of search stuff, they like, they expose like grep and find and whatever.
hmm
Um, and they were talking about this. I think it caught people's imagination as well.
hmm
And there's definitely some appealing bit about it. It makes sense. Like it's kind of feels, this is an aspect that, yeah, it definitely feels like a simple approach. And you can
hmm
like wrap your head around it because you're basically
hmm
telling LLM to act exactly like a human.
hmm
How does that relate to the things you're saying? Like, is there anything that you would disagree with, or is it the same? Like,
I mean, it's
are you
like
aligned with it,
catastrophic.
or
It's
yeah?
a catastrophic latency, catastrophic reliability. It basically boils down to this text to SQL idea. Like, imagine that uh, you are a product manager at TikTok and you are like sitting there and thinking, okay, how should we in half a second figure out what the user should see next so that we can have the leading whatever personalization engine powering our feed. And then somebody would say, well, just like let the LLM look at what the user clicked on and it's going to do some searches in our content catalog. It's going to figure it out and it's going to surface the next item in the TikTok feed. Like this is just insane, right? But that should be your standard for everything, right? It should this like in terms of latency, in terms of personalization of these experiences, this stuff needs to happen in, where are all these stats with how every whatever 50 second of
Mm.
latency drops your orders by whatever percentage, right? Um, yeah, I think it's very appealing to think about it that way that the LLM will like explore the existing tools and is going to somehow cobble together the answer. The two problems, of course, is that when the LLM is judging the things that come back, it's judging it through the lens of strings, and to the extent there are descriptors of these objects that you are asking it to kind of merge across these different search queries and systems, it fundamentally doesn't understand numbers and locations. So it's gonna do some like very approximate thing. And it's gonna do it super expensively and kind of not reliably and slowly, right? So, but it's easy to get started. And this is kind of the appeal of in general having an LLM API, right? It's just you can stringify things, you can make a prompt, and it does something, right? And perhaps for if you are not if search and recommendations and whatever retrieval for agent that's putting together an outfit or putting together a contract, right? And it needs to kind of go to a bunch of places and do retrieval. If this is not, like core, then maybe you get away, at least for the next, half a year or a year, you get away with just using the existing tools and then putting the LLM on top. But yeah, the problem is that the navigator of the process looks at everything through the lens of text. And actually, most of this data and most of these descriptors of stuff coming back from these tools might not be textual. And then those underlying tools also are, built. They have existed for a long time. They have been designed around, people doing searches and us being able to evaluate these search queries super efficiently with inverted indexes and all of that basic stuff. But they can't reconcile all these different needs, right? Like this, to reconcile this in that underlying tool, you need some kind of, you need like fuller representations of the things you are searching for and also of the queries. And if you try to cobble this together with just an orchestrator on top of old school search stack, it's going to be slow and it's going to not take all the signals into account properly. And you will never have an experience of the TikTok feed that way. That's kind of in my
So you're
opinion.
saying like, okay, for this example on the slide right now, the
Hmm.
popular family-friendly hotels and whatnot,
Hmm.
your argument is like, hey, like, okay, so you could have an LLM, give LLM access to like traditional database and say like, hey, given this, like construct a query,
Hmm.
like construct maybe even a SQL query. Let's suppose that like, like your system has a way to like understand location and calculate distance like inherent, like the language model is not doing that.
Hmm.
Um, are you saying like it would be better if you can encode all of these different things into some encoding that is much
Hmm.
more efficient to capture all of these things and then like sort like what are the most family friendly hotels,
That's
you
right.
know?
Like in much more resolution, like incomparable resolution, because the word popular itself is like super loaded. It might be the distribution for that might be specific to the user, specific to the query, right? Like you trying to figure out some kind of global boost weight on popularity and hard code it into your open search query. It's, like Bronze Age thinking, right? Like somehow this specific user writing this specific word into a query, you know, in the limit, there is like I don't know how many hundreds of bits of
Hmm.
information hidden under that one word, right? Uh,
For sure. So in your kind of view, like you have a carefully constructed embedding like that accounts for all of these things, like,
mhm.
and then it's able to retrieve, you know, what you're
Yes,
looking for. It's no,
I mean that should
there's
be
no like
that
query decomposition step and
No, there
something.
is query decomposition step.
Okay.
I'm talking about the limit. In the limit, right?
Okay.
You want to be modeling all these things in the most resolution possible, and then this is a filter, okay? Under 400 is very explicitly a filter. You should attach that to the embedding. But everything else that's like smooth preference distributions, you should try to model as accurately as possible, as contextually as possible. And then also then on the other side, when you index your data, you should try to capture all the different signals you know about the data and also represent it as best as you can. And again, for a long time, the consensus is that embeddings are the way that we make these representations. Maybe you have one vector, maybe you have many vectors in case of late interaction, but basically it's just a way to pack a bunch of signal bits into some kind of unified structure, which we know how to index, right, with the approximate nearest neighbor search indices, right? This is kind of the other side of the coin that you have a way to pack a bunch of bits into a representation that you have this operation over that in sublinear time finds you similar ones, right? That's the underlying kind of engine for these queries. But it's totally up to you how and how much information you pack into that vector. And um, when you come from training custom encoders for these kind of feature engineered entities, you just think about it as like, okay, all the signals, how am I encoding them? If you come into this from, picking up vector search in the last couple of years with the open source or OpenAI text models, your mind is sort of just focused on, I have some text and I can make vectors, or I have images and I can make vectors. You are not yet thinking, and I think you should, in the framework of how do I take everything, all my observations about the user and make a vector out of that, right? That's I think the journey that takes you to something like that TikTok feed, and whatever your variation of that is. And my assumption is that everybody has a variation of this problem, basically. Okay, we have
Let's
some
ask a
hands
questions.
also.
Yeah, just some hands.
Yeah, yeah.
Sharang, do you want to ask a question?
Yeah, they're pretty cool, Daniel. So I've been seeing this search issue in manufacturing. I've been in manufacturing all my life with Autodesk and now joining Siemens.
Mhm.
All kinds of ERP, PLM, content libraries, they all have this kind of an issue actually. And giving a text-based search is super powerful. And if you're saying, and I think you already answered part of the question is that the signals or filters are becoming part of the embedding itself now. So you have a way essentially of converting domain-specific attributes into the vectors is what you're saying. It's every
Yeah.
enterprise can build those bridges, filter bridges, essentially, so that the vector can be augmented with this information.
Uh, almost right. Basically, I'm saying filtering is kind of the one thing that you want to keep doing with either sparse vectors or like whatever the filter support of your database is. Because if you really want like a yes no kind of thing, right? Like let's say a real estate agent only sells products, houses in this zip code. Okay, so you need a zip code filter. There is no way around
Mm.
that. Um, but all the fuzzy things like
Mm.
near and popular and for me, and show me users that behave similarly, like all of those things that kind of sound fuzzy, uh, fundamentally should be done by basically inner product or cosine similarity. And it's all about how do you pack as much context into the vectors for the data and for the queries.
Mm. So enterprise essentially are giving you the signals and they get encoded in the vector.
Exactly right. Yes.
Got
Yes.
it. And I remember you and Hamel talked about yet another time about evals, and you said in this case is essentially up or down, the signals are bad. You want a sort of a gradation of that so that you can train the model the right way. You can do backpropagate and train the model the right way.
Yeah. Yeah. I mean, the more fine-grained signal comes from your eval, the more you also know if you are moving in the right direction. The standard is this ESCIS, right? Like relevant, not relevant, whatever replacement, very coarse, very few labels. And I mean, in general, of course, the best label is the USD, right? We always say that the best eval metric is, are we selling more t-shirts? And if you have a way to back propagate that, that's useful. But the thing is that if you try to be too clever about that, you will spend a lot of time on one project. And this is what I think a lot of kind of ML folks in companies don't fully get, is that I think you should maximize your impact across as many projects, right? So it's like project count times KPI lift, right?
Right.
And the idea is that, yeah, like if you can productize this process where, the way we have done it is by composition of these either pre-trained parts or auto-trained parts, then you can just ship more stuff and get promoted.
Thank you. I'm definitely going to look at your GitHub. Yeah. Thank you.
Cool.
Raymond.
Hey, I have a super quick one because I got to jump in just a minute, but I just a lot of my interests are in 3D modeling and 3D like CAD and stuff like that, 3D generative AI, and I'm curious if either your tool or you've seen any other tools that can like embed 3D geometries.
like point clouds, basically.
It could be, yeah, it could be BREP, point cloud mesh. I'm open-minded. There's people, fine tuning models to like literally turn point clouds into code or things like that. But I was curious if you've seen anything on the like pure embedding side.
Yeah, I mean, the closest I got to this topic is molecules. So molecule embeddings.
Yeah,
but
Ash. I don't know if you know Ash Verdanian. He has some really cool
yeah, I
project.
play basketball with Ash. So
Oh yeah. Cool thing embedding molecules.
Yes. So yeah, definitely a lot of work to be done. No specific work yet for us on the point clouds. But
Cool.
I would love to connect, and if you find something,
Yeah. I'll shoot you an email.
That's good.
Yeah.
Okay.
Cool. All right.
Thanks. Anybody else questions? Everything super clear, straightforward?
I have a lot of questions, but I was just gonna save it for another time. I'm gonna like send you an email or something. We'll take it from there.
Yeah, which by the way, if folks want to do that, something comes to mind, or you are looking at the GitHub repo, or something, you maybe review the slides afterwards. I'm at daniel@superlinked.com, so feel free to just shoot me an email, or maybe even better, just connect on Twitter or LinkedIn. I'm just my surname, Svonava, on all those platforms. And I also posted my LinkedIn to the chat here. Yep.
All right. Thank you.
Cool. All right. Thank you very much, and have a good rest of the course, and good luck out there.
All right. Thank you. Thanks.
Cheers.
Thank you.
Bye.